So we'll be doing Gauss-Jordan elimination, which is a method for solving linear systems. So what we'll be doing is take this linear system as an example and try and solve it using the Gauss-Jordan method. So we have three equations in our linear system with three unknowns, x, y, and z. So we'll use the Gauss-Jordan method to try and find its solution. So the first step in this method, it's the same first step as in Gaussian elimination, which is to build an augmented matrix from the system. So this is the corresponding augmented matrix. Let me use a nice pen. So you have a constant here. Yeah, I don't want that. They're put on that side, and then 2x goes there, 3y goes there, 4z. So basically this is the first equation, this is the first row, second equation, second row, third equation, third row. There were no x's here, thank you. There were no x's here, so we've put a 0 here. So this should be obvious enough at this point. So let's remember what we're allowed to do with an augmented matrix, because the Gauss-Jordan method is about obviously transforming this augmented matrix into a form that makes it easier to see, for example, what z is worth. So we'll have to transform this matrix using obviously operations which we're allowed to use. These operations, what are they? Again, you should already know about this, but let's just remind ourselves what we're allowed to do. Elementary row operations, what are they? Move a row up or down. Let's say I want this row first, I can move it up, makes no difference. And if we think of the fact that this augmented matrix actually is just basically a rewriting of the system, if I was to take this equation and say, oh, I want to put it first, obviously it makes no difference. So moving a row up or down, multiply a row by a constant, as long as you do it properly. So let's say I do 2 times the second equation, I have also to do 2 times this. So 2 times a full row, 3 times whatever. A row times a constant is completely allowed. And then add one row to another, and you can also add a constant times a row to another row. So basically 2 times this row, I add that to this row, I'm allowed to do that. And again, if we think back of the fact that an augmented matrix is just basically a rewriting of the system, then these elementary row operations completely make sense. So we'll be using these row operations to transform our augmented matrix into another form. What is this form we're trying to achieve? It's called the reduced row echelon form. We're trying to change this matrix up here using elementary row operations. Oops, we're trying to reach the reduced row echelon form. When we'll be doing this, we'll actually pass through the normal row echelon form, so the not reduced. So we'll pass through this and then we reach that. If you don't know what these forms are, you should probably open your Anton book on page 11, I believe. Yeah, it's on page 11. So you can either open the book on page 11. If you don't have the book, you should go and look up Wikipedia. That's you, that's different. And find the definition of row echelon form. So the example they have here is pretty good. So you should do that now. If you don't know what reduced row echelon form is, do that now. Wikipedia or your book. So pause this video and come back once you know what I'm talking about. And actually I'll pause this video, go and look it up, and then we'll start doing this Gauss-Jordan elimination on this matrix in the next video.